Assalamu alaikum, ladies and gentlemen. My name is Dr. Bilal Wajid, and I welcome to you another lecture of discrete mathematics. Now, in the last three lectures, we discussed the number zero and how numbers behave when they're added, subtracted, multiplied, divided by zero, and when x is raised to the power zero. This particular lecture is dedicated on factorial. What is zero factorial? Now, before we start discussing what is 0 factorial, let's ask what is x factorial? Well, to start, 1 factorial is equal to 1. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. And you can see the trend here that n factorial starts at n and ends at 1, where it's n times n minus 1 times n minus 2 all the way till 1. Now, if you look at this particular function again, you'd realize that what really we are doing, we are starting from n, right, and going all the way till 1. That is why you see here that I starts from n and goes all the way till 1. Because of the commutative law, you can also multiply backwards. So you can start from 1 and go all the way till n. So n factorial could have been rewritten as n factorial is 1 times 2 times 3 all the way till n, where we see here that we flipped the limits, where I now starts with 1 and ends at n, as is visibly shown in the equation here. Now, given that, we still are asking, what is 0 factorial? Now, let's repeat that again, and this time, we'll see how it works out. Well, you've seen these, all of them. But what you'll notice here is that all of them begin from the number n and end at the number 1. Now, let's put all of this on the left-hand side, right? The way you see here. Now, we could have rewritten 1 factorial as 1 times. Rather than ending at 1, let's somehow end at 0. So rather than, writing 1 factorial is 1, we could say 1 factorial is 1 times 0 factorial. Similarly, you could say 2 factorial is 2 times 1 times 0 factorial. Similarly, you could say, well, 3 factorial is 3 times 2 times 1 times 0 factorial. You can say the same for 4 factorial. You can say the same for n factorial. Now, the only number that allows the number to remain the same is 1. Therefore, 0 factorial has to be 1. Only if it's 1 would this be true. But, wait a minute. You could say, well, by that definition, you can actually go and extend this all the way till infinity and say, well, minus 1 factorial times minus 2 factorial, all of them are equal to 1 by definition. And this could go all the way to negative infinity. That sounds a little weird. So let's try another proof. Now, this one, we're going to start determining what is 0 factorial by looking at a smaller closed form expression of n factorial. Now, let's look at this. 1 factorial is 1. 2 factorial is 2 times 1, which is 2. And we realize here, well, we could replace this 1 over here with 1 factorial. And so we did. 3 factorial is 3 times 2 times 1, which is 6. And we realize, well, 2 factorial is 2 times 1, which is 2. So we can replace with this 2 times 1 with 2 factorial. And so we did. Similarly, 4 factorial is 4 times 3 times 2 times 1. And we can replace all of this with 3 factorial. And we did. And what we see now is this closed form expression of n factorial, which is n times n minus 1 factorial. So using n factorial as n times n minus 1 factorial, let's look what is 3 factorial, where 3 factorial is 3 times 2 factorial. Now you can put this 3 on this side in the denominator and make 2 factorial as the subject of my equation. And what we get here is this. Now this is the same as 6 over 3, which is 2. Doing the same with 2 factorial, we can, do the same. We can put this 2 in the denominator, make 1 factorial the subject of the equation. We get something like this. Solving this, we get 1. Now, let's do the same with 1 factorial. Now, 1 factorial is 1 times 0 factorial. Well, you can put 1 factorial in the denominator and make 0 factorial the subject of my equation. You get something like this. We know 1 factorial is 1, right? And 1 is 1. So 1 over 1 is 1. So we realize 0 factorial is 1. But wait, there's more to this. You can actually continue this and figure something important out. Let's just go one step ahead. You've already seen this, right? 1 factorial is 1 times 0 factorial, 1 going in the denominator. You're only left with 0 factorial, you get 1. Let's look what's 0 factorial. Well, that 0 factorial is 0 times minus 1 factorial. Okay, that's fine. Let's see where this goes. Let's put 0 in the denominator. You get some, and let's make minus 1 factorial the subject of our equation. We get something like this. Okay, now we know 0 factorial is 1, but 0 remains 0. And what we have here, anything divided by 0 is undefined. So the negative, the factorial of a negative number, that means is undefined. In fact, x factorial is undefined for x anything less than 0. So, in conclusion, through this lecture, we proved that 0 factorial is 1. We proved that x factorial is undefined for x less than 0. In fact, x factorial is only defined for whole numbers. So that means 0, 1, 2, all the way till positive integers. It's not even defined for decimal numbers like 2.34 factorial. That's nothing, right? It's only defined for whole numbers or 0 and positive integers. Well, I hope you liked this lecture. We finished, with 0. There's one more lecture ahead, and that's interesting. I haven't put it here, but there's another interesting lecture left for 0. I hope you like my work. I hope you like the teaching. I don't know if you've noticed, but it took 62 slides for this few-minute videos. So a lot of effort goes into making these lectures. Until next time, thank you very much. Bye-bye.